All right, so what you're looking at is you have this box that you're trying to create out of a single sheet of cardboard. So here's kind of the 3D view of it. The two-dimensional view is just a cardboard sheet that is 30 centimeters by 40 centimeters. Okay, and so what you're trying to do on this is you're going to fold this box and cut out the corners. So if you fold the box here and here, as well as along here, and you cut out these corners, you'll be able to create this three-dimensional box. And so it's asking, you don't know exactly what your dimensions are, but you do know they have to be the same because you're removing this piece. This is your x value. So if we remove an x from each of these pieces where we're cutting it out, okay, what is that going to leave us for the whole dimension along here, which I'll call this dimension right here? We took this whole length of 40, we removed an x from each side, so that's given by the expression 40 minus 2x's, right? So that's the expression of that dimension, or that side. And we're doing the same thing here. This dimension is just this length. Well, this length is accomplished by taking the whole length of 30, subtracting an x from each of the corners. So it is 30 minus 2x. And so now you have the three dimensions of this box. And so to find the volume, you're just going to multiply those. So x times 30 minus 2x times 40 minus 2x. And so if we just expand this out, and then take a look at our graph of it, the relative maximum on the graph for that is going to give you the highest volume that you can find with those dimensions. So if I take this and I put it into my y editor, just as it is, so x times the quantity 30 minus 2x times the quantity 40 minus 2x, and I enter that in my calculator, and then I go in and view it. So once again, I mean, my viewing window wise, I've extended it pretty high. All I need to do is find my relative maximum. This value right here will give me my highest possible volume that I can get based on these dimensions. So if I use the F5 Map tab, select maximum, choose my lower bound. Again, as I scroll through, you can see the cursor coming. Now it's to the left and below this relative maximum. So that's my lower bound. I can scroll to the right and below for my upper bound. And this is going to give me the dimensions that I'm looking for. And so I wound up with an answer 5.6574148, and then the volume 3032.3025. So here's the coordinates of my maximum, my relative maximum. And so that's going to give me the following information. Here is my smallest side. So if I round it to the nearest tenth, 5.7. And here is my volume. If I round it to the nearest tenth, 3032.3. So that's volume. This would be my small side x. And then all I need to do to find the other two pieces is I take this measure and I plug it into x here and here. And these give me my three sides. So my small side, my large side, my middle side. Once again, they may have just used the 5.7, so let me test it and see. So if I took 30 minus 2 times 5.7, I get 18.6. So that's this length. And so again, it looks like they used the rounded off number for each of those. And then the larger one, if you just change the 30 to a 40 minus 2x, you get 28.6. And so those would be your dimensions.